Hello everyone, welcome back to another new video. In this video, we are going to solve one different types of numerical than previous one. Okay, in this question, we have a slope deflection method. Okay, and before this question, we have already done more than 15 numericals on the slope deflection equations. Okay, and on all those videos, we don't have applied any couple at intermediate span. Okay, but in this question, this concept will be new. Okay, for you, you can see here 180 kilonewton meter couple is applied over here at the for the span A to B. Okay, and 30 kilonewton meter UDL is applied. Now we have three different support. These two are the fixed A and C, and this B C support is the roller support. Okay, so we need to solve this by the slope deflection method. Okay, before this video we have done so many questions, but on all those questions there was no any couple applied. Okay, but in this question 180 kilometer meter couple is applied at the AB span, so this concept will be new for you. Okay, so watch till the end. So first read the question. Analyze the continuous beam. We have a given beam and we have to analyze it. It means we need to calculate the final moment. Okay, and also draw beam and shear ACF diagram. It means we have to draw bending moment diagram and shear force diagram as well. Okay, so now let's start the solution. Okay, so before going to solution, if you are new to the channel, please do like, share and subscribe the channel, and you can watch all the important videos on civil engineering for your final examination on this YouTube channel. Okay, you can go and watch from all the playlist, and if you are preparing for your final examination, then you can also join our WhatsApp and LinkedIn group. Okay, from there you can get all the PDFs, important world is gold solutions, and past questions, video lectures on free. Okay, so you can also join us. Okay, and we are also going to start 15 days crash course, so you can also get more information from that group. So please go and join our WhatsApp and LinkedIn group. Okay, so now move to the solution. So in very first, as we know, for any slope deflection equations, in any problem related to slope deflection, we need to perform three different steps. Okay, first one step is calculation of fixing the moment. Second step, slope deflection equation. Third step, equilibrium condition. We need to apply these three steps. So let's see the first step. So our first step is fix in moment. Okay, so if there is any couple applied between any span, then we have the formula m plus b 3a minus b 3a minus l by l square. So this is a. Look, here is a this 180 kilonewton applied. So this is a and this is b. So if we are looking from left to right, so a to b will be the value of b will be 2. So the b will be 2. 3 is the formula 3, and the value of a is 4 minus 6 by l. L means total, that is 6. 6 square, we get 60 kilonewton meter. And similarly, for B to A, if you look from right to left, there we need to just change the value of A and B. In the place of B, we need to take A. In the place of A, we need to take B. And all the values are same. So this value will be 0 kilometer meter. Okay, so only this much concept is different. So what is the difference between previously all videos and in this? In this video, if there is any moment is applied between any support like this 180, you need to remember these two formula. Okay, m plus left to right b 3a minus l by l square, and m a 3b minus l by l square. Only this much different, and you can calculate all the remaining moment. Okay, and you can solve as well. No need to worry. Okay, all the procedure and all the steps are the same, but if you forget this formula, you cannot solve. Okay, so keep in note this. Okay, now we need to calculate friction moment for B to C and C to B. So this is UDL, so you can calculate by directly applying the formula. For the UDL case, we have the friction moment formula WL square by 12. So the value of W is 30, L is 4 by 12. And from left to right, we need to take a minus symbol. So we got 40. And for right to left, we need to take plus symbol, only this much. So it means 40 kN. So we calculated the first step. Now let's move the second step. Second step is slope deflection equations. So 3. So you can see here, we have to just apply the slope deflection equations, and we need to put all the values. So we get friction moment AB is 60 and the value of L is 6, and you can look in the our beam. This is A support is fixed, A, B and C. A and C are fixed support. It means theta of A equal to 0 and theta C is also fixed. So theta of C equals to 0. We need to take these two values 0, and there will be no settlement or sinking. So delta will be also 0. So this will be 0. This will be 0. So remaining is this. And for B to A, friction moment we have calculated. So we need to put 0, and the value of L is 6, and here also we need to calculate only B, and theta A and delta A is 0, so we need to put 0 0, we got this value. Similarly for the BC span, you can see for the BC span also we have theta B only unknown, and theta C and delta is 0, so we need to put this value 0, and we got this one. Similarly for C to B, this theta B only you need to calculate, and theta C and delta is 0, so we need to take 0 0. So we have put 0 0 value, and we got these equations. Okay, so from here we got to 4 equations. Now we need to apply in step number 3 equilibrium conditions. So for the equilibrium conditions, you can see here we have a 3 different support A, B, C. So we need to take moment at B equals to 0, sum of moment. It means left of B, that is BA plus BC equals to 0, we need to do. Okay, so for the equilibrium conditions, we have to apply summation MB equal to 0. So the value of MBA is this one, BC is this one, and we got EI theta B equal to 24. In this question, the value of EI is not given, so we need to take EI. If and you can also assume if there is no value given in the question, then you need to take EI equal to 1000 kilonewton meter square. Okay, whatever your choice you can take or put the value. And now we need to put these all the values. EI theta B is the given 4 equations, these 4 value. Okay, in this equation this and this, and we need to calculate this all the moment. Okay, and we got final moment. So look here, we need to put all those values in the given slope equation. So we got these 4 equations and 4 final moment. Okay, so in this way you can calculate, and for the final reactions you can see there is a 180 and this moment is applied over here. Okay, and if you do sum of moment at B equals to 0, okay, at the point B equals to 0 we need to calculate. So these two will you need to consider. So 68 into how much, 66, so we need to do this value. Okay, and add these two value. From here we got these reactions, and we need to just make the bending moment diagram. Okay, so for bending moment diagram, as I said already, we need to consider this minus plus plus minus, this sign convention rule. If we are looking from left to right, then we need to take negative value as upward. So From A to B, you can see here we got a positive 68 value. It means positive value is below than this beam. So this will be below than this 68 over here. If we have negative value, then we need to take this upper value. Okay, and similarly we have calculated this all the values, and here is UDL applies. So for the UDL we need to make curve. Okay, and for the point load we need to take this. Okay, for the point load maximum value will be WL square by 8 for the UDL, and for the point load PAB by L. You need to apply this formula and you need to make this. I have already explained in so many videos how to draw beam bending moment diagram, so you can also go in the channel and watch all those videos related to slope deflection equations. Thanks for watching. Thank you very much. Please do like, share, and subscribe to the channel.